Great. So welcome to this lesson on chemical reactions, an introduction actually to chemical reactions. We've learned a lot about atoms, molecules, and all these different substances, but we haven't looked at yet how they can change. And this is what chemical reactions are really about. So we're going to say, what is a chemical reaction? Well, chemical reaction is the term used to describe chemical change. That's in its most simple, most basic form. When things change chemically, then we call that a chemical reaction. Normally, things just stay, items, are staying in their regular state, everything's fine, they're not changing chemically. But if they do change chemically, then we want to call that a chemical reaction. Now, we should understand there are things called physical change, and you may have studied that in the past. For example, when the snow melts to water, snow is still water chemically, and vice versa. We can make it into ice, and then eventually into steam. All those things are the same substance, and they don't really change chemically. So it occurs, a chemical reaction occurs when one or more substances change into a new substance with new chemical properties or new chemical and physical properties, okay? And so this means that new things are being made. I kind of like to put it in, when you're looking at it from a chemistry point of view, in a more simplistic way, and say a simple way would be to say that when the chemical formula of a substance changes, okay? So if we take the chemical formula and we change it, then there must be a chemical reaction, okay? So chemical reaction is changing those chemical formulas, as opposed to, other things. Like if I took a piece of paper and cut it up into tiny little pieces, I'm not really changing the chemical constituents of that piece of paper. They're really the same thing. I might not be able to put it all back together exactly as it was, but it's still the same product. Just because I tore it up doesn't make it a chemical change. But if I took that piece of paper and I smacked a lighter to it and I burned it, then all of a sudden we get all these new things being made. We can smell the carbon dioxide is being produced and various other things, and the paper turns all black and new products start to form. And so then we have a chemical reaction, okay? And maybe you've studied in the past, some things that indicate a chemical reaction versus those that don't. Things like, smell, the change of color, uh, a gas formation of a gas, all those kind of things that are sort of indicators that we have some sort of a chemical uh, change or chemical reaction. Okay, in this section though, I'm looking more at it from a chemical or looking at the chemistry of what's happening in chemical reactions. Okay, so not the physical evidence of it. So an example is if we took hydrogen gas and we combined it with oxygen gas, believe it or not, we can make water. And actually, we can actually produce quite a bit of energy. This is how they actually make energy for, I think it's those special kind of batteries, hydrogen batteries that produce electricity. So they can use that to this process to generate energy. And you'll notice that it can also be written in its chemical form. Okay, so this here is the word equation, and down here is our chemical equation. So H2, and then we put in brackets G for gas, and then O2, and put in brackets G for gas, and it will make a liquid, H2O. And so this is the chemical formula that we typically use. Now, for every reaction, there are things called reactants, and these are the things that will react, okay? And we have products, okay? Let me highlight these in two different colors, and then I'm going to go back. I'll erase my wonderful work here, and I'll do the same thing. I'll say my reactants are here, the hydrogen gas. This is what we're starting with, and then we produce water, H2O, and so they're called the products. So if you want to kind of make a connection there, these two, this is the products, and these two here connect to be the reactants, okay? My arrows are a little off there, sorry. Struggling a little bit with the pen this morning. And Reactants are the substances when a chemical reaction starts, okay? So when we start a chemical reaction, we have those items there. So that's the beginning, okay? And then after we have new formed, these are the products. The new formed substances are right here, okay? And so we can do we can ask some questions like, what are the reactants here? Well, the reactants here are H2 gas or hydrogen gas and O2 oxygen gas. All right. And what are the products? What are the things that are being made? Well, in this case, it's water, or we could write it as H2O, and it's a liquid. Okay. And you'll notice that we're consistently stating the state, which is gas, liquid, solid. Those kind of things are often included, almost always actually included in your chemical formulas or the formulas that you write out an equation for chemical reaction. So any chemical reaction can be described using two methods. Okay, so we can use one of two methods. One is to go with a word equation, right? We can use a word equation here like this: carbon solid plus oxygen gas. And then we usually always use an arrow. Sometimes we use a word like becomes or goes to or whatever, but usually an arrow, carbon dioxide gas. So if we were to take solid carbon and mix it with oxygen gas, we can actually make carbon dioxide. Okay, I'm not sure if they actually do that very much, but maybe that's how they make carbon dioxide gas. Believe it or not, they make carbon dioxide gas for certain special functions, although not very many. Okay, now the chemical formula, the chemical equation way to write that would be carbon symbol, the symbol for carbon, C, followed by a small brackets there. I zoom in a little bit. It seems a little small for me. I don't know, an old man eyes here. And you can see that the little S's, that's a subscript, and then oxygen, O2, and then we put gas in brackets behind, and that becomes carbon dioxide, CO2, and it becomes a gas. Now this would be a molecule because it's two nonmetals that are combining, but that's a simple basic equation for it. And you'll note that so far we're always putting in the state of both the reactants and the products. Okay, so that's a very common thing. So S stands for solid, L stands for liquid, and G stands for gas. And then there's this other one you'll see from time to time, actually quite often, AQ. And AQ means aqueous, meaning it's dissolved in water. Okay, so if we have something that's dissolved in water, water is a huge place where a lot of chemical reactions occur. And so some substances are just in the water. And when we dissolve them in the water and then mix the items, then they become aqueous, they call that. Okay. That's a fancy word for in water, aqueous. Okay, so consider the following reaction. Okay, so we can start to use, names that we're familiar with. Okay, so this is aluminum solid reacts with water, H2O liquid. So if we presume we put some aluminum into water, and what do we produce? We produce aluminum hydroxide. Remember, that's a polyatomic ion that we learned in a previous lesson, and it's combined with the aluminum, and it produces aluminum hydroxide, okay? And hydrogen gas, H2 gas, okay? So we can say what are the reactants and what are the products. So we can say aluminum solid is a reactant, and you could write that either way. I don't usually write it both ways, but you could, aluminum. And again, I don't usually write solid, but I'll just put it in brackets. And then I could say water, okay, and H2O or H2O, whichever one you prefer, and then liquid. It's a liquid. Those are my reactants, okay? And then what are my products? And again, I could write it as a word equation, or I could write it as a um, the chemical formulas. I'm going to do both, okay? So I can say AlOH3, and that's aqueous. It's going to be in water, okay? So that's aluminum hydroxide. And if you're not sure how to spell these things, they're given to you in a chart, okay, in a previous lesson that you looked at, okay? And this is a aqueous too, okay? So I just wrote it both ways. You don't have to do that. If you're answering it, you could either write it as this or you could write it that. I don't care. And the other one is hydrogen gas, okay? And again, I can write that as H2 or hydrogen gas, whichever you prefer. Now we can write the word equation for this. So if I was going to write the word equation, then I have to basically take all the words that I've put here and put it together into an equation. So I say aluminum solid, okay, and I am using the bracket symbols here, plus water, liquid, goes to aluminum hydroxide, aqueous, I got to say that it's aqueous, and plus hydrogen. And I do need to put the little g in for gas, okay? And so that is the way it basically moves along the, um, it's basically the same thing as writing this here. It's just writing it with words versus writing it with symbols. Either way, whichever way you prefer. And you should be able to do both methods, essentially, is what they're saying. And then it says, what's the state of both compounds containing aluminum? Well, the first one is solid, and the other one is aqueous. You could write them as their symbols if you wanted, right? Solid and aqueous. And it doesn't say to indicate which one is which, although if you wanted to, you could, but it's kind of obvious, okay? Now we can also do this if I just give you a word equation. I'm not asking you to write the, from a word equation, you could be asked, but I'm not at this point asking you to do that. So this is going to be carbonic acid in water combine produces carbon dioxide plus water. Okay, so the reactants are carbonic acid, and it is aqueous because it's in water. Okay, and then the products are carbon dioxide. You could write, if you want to write the symbols, you can. I'm not going to mark you wrong. And water. And again, you could write the symbols for that as well, which is, of course, a liquid. Water is going to be a liquid. We don't even have to state it, but we probably should. I could look up what carbonic acid is because I gave you a list of common acids and you could see what carbonic acid is. And you could actually write the chemical formulas down. You probably all know what carbon dioxide is and you know what water is. And so if you just had to look up carbonic acid, you could have wrote those down there as well. That information should be made available to you as, you know, the common acids and polyatomic ions. You have those charts available to you. And then write the chemical equation. Oh, well, if you're going to write, oh, we are actually going to write the chemical equation. Well, then I'm going to need to look up my reaction tables. So I'm going to go and open up a file that has that information in it, okay, which is actually right here, okay. And I got to look up what the heck is carbonic acid. And so here's my acids tables. And there it is, H2CO3. So I needed to know that. I wasn't 100% sure what it was. I was pretty sure, but wasn't 100% sure. So I got to go look it up, and you have those available to you. So I just go back to my other thing here, and I'm going to say H2CO3. It's going to be H2CO3. And that is going to become carbon dioxide. Oh, by the way, that is aqueous. Don't forget your little aqueous symbols. CO2 which is going to be a gas, plus water. Well, what's water? H2O, and that is a liquid. So I've now written it as a chemical formula. Pretty cool, right? And what is the state of both compounds containing carbon? Well, the first one is aqueous, and the second one is carbon or solid. Nope, I apologize. It's not. It's a gas. And the second one is a gas. And so there we go. We got aqueous and a gas, and we have essentially answered the questions there. Now there's a series more questions for you to consider just to go through, looking at our basics for chemical equations. Again, don't panic. Remember to use your polyatomic ions chart if you need it. Use your basic acids and bases if you need it. Look things up, and you'll get your way through some of this stuff. And this is just sort of an introduction into um, chemical reactions. All right, hope you enjoyed the lesson. We'll see you next time.